This video is the second that covers the topic of backtracking. Be sure to put your date and the topic at the top. Our essential question will be, how do we use backtracking to find an unknown number? Be sure to write your essential question on your notes. Sometimes I'm seeing that people are forgetting that, so just a reminder to always include your essential question. We've used a model or a visual to find an unknown number, so we'll just do a quick review here. Here we have an unknown number represented by n, and we can see a series of operations were performed on that number, and it resulted in 2. So take a moment and backtrack and see if you can figure out what my number was that I was starting with. Let's see if you can tell me what n equals in this situation. How'd you do? Did you see that my missing number was 5? I can double check that that makes sense because 5 times 2 makes 10, minus 4 is 6, divided by 3 is 2, and that's where I should have ended up. We use backtracking to solve algebraic equations. Let's take a look at one. Here we have an algebraic equation, 3 times some number, 3n, plus 4 equals 10. We can backtrack to solve this. I'll start by using the model. The first thing I know is that I'm starting with some unknown number using the variable n. I then know that the first thing that's happening to that n is that it's being multiplied by 3. From there, we are adding 4, and as a result, we get a total of 10. So we can backtrack just like we've done before to figure out what my number was. I would, of course, subtract 4. Right? 10 minus 4 would give me 6. And then I would divide by 3. N would be equal to 2. Right? And that makes sense. 3 times 2 would give you 6, plus 4 equals 10. So it's the same idea as our normal backtracking. It's just learning how to change this algebraic equation into a backtracking model. Let's try another. Here we have an algebraic equation, and I'm using x for my variable this time. And I have in parentheses x plus 3, and that's happening first because that's in the parentheses. That happens first to my variable. And then I see this number 2 outside the parentheses. If I ever have a 2 in front of a parentheses, it's like there's an implied dot there. It means it's being multiplied. So if you ever see that and there's no other operation, it always means multiply. So I'm going to set this up like I've done before with my boxes, and I'm going to fill in what I know. I'm starting with a variable x. I know the first thing that's happening is that we're adding 3, because that's what's in parentheses. I then know from there we are multiplying by 2, and I'm getting a total of 14. Right? So now, using your normal backtracking tricks, take a moment and see if you can tell me what x is in this equation. How'd you do? Did you find out that the missing number was 4? You can double check that, of course, right? Because 4 plus 3 would give you 7, and 7 times 2 would be 14. So we know it works. Right? Same thing, same backtracking as before. We're just taking an algebraic equation and turning it into a backtracking question. We'll do one more. Here's our last one. And there's something a little different in here, and it's something we need to know for the future. This line here, right, is our division bar. It looks like a fraction bar, but that's exactly what a fraction bar is, right? It's showing us division. So when we look at something like this, we want to know that whatever is happening on top in the numerator is all happening together, and then the last step is that it's being divided by whatever in the denominator. Okay, so let's keep that in mind, and we're going to set this up as we do our other backtracking. So what we have is 2 times some number. This time I've used f as my variable. And we're multiplying 2 times that f, and then we're subtracting 4. And then after that, all of that is being divided by 3 to get us a total of 12. So we would have the f, right, is being multiplied first by 2. That's the first thing that's happening. Then it's having the operation subtract 4. And from there, everything is getting divided by 3. That's what that line tells us. So again, take a moment, backtrack, and we'll see how you did. How'd you do? Did you find out that my missing number, f, was equal to 20? Right? Let's see if that makes sense. 20 times 2 is 40. 40 minus 4 is 36. And 36 divided by 3 is 12. So it worked. Right? So again, this is not anything new, right? We're still just using backtracking to find an unknown number. That's what our essential question was. But it's just this time trying to make sure we can take an algebraic equation and use the backtracking model to help us find our missing variable.